we're going to start looking at converting mixed radicals to entire radicals. So right before this section, we were talking about going the other way around, going from an entire radical to a mixed radical. So now we're going back. And so every mixed radical we can express as an entire radical where the whole number is under the radical sign. And let's look at how to do that. So let's complete the following to convert 4 times the square root of 5 to an entire radical. So 4 square root 5 is my mixed radical, and I want to bring it in, and I want to express this as an entire radical. So as an entire radical, this is going to become 4 squared. If I put 4 squared essentially back into under my radical sign and express it as a radicand, it's going to be 4 squared. 4 squared we know is 16, and if we have 16 times 5, we would have the square root of 80. And so if we were to square root of 80 and 4 square root of 5, we're gonna end up with the same values. So again, I took this 4, and because of this index here is a 2, it indicates that I need to square 4 to bring it back under the radical sign. 4 squared is going to result in 16 times 5 is square roots of 80. So class example number 9, we want to convert these following mixed radicals to entire radicals. So 2 to go back into the 6 would be the square root of 2 squared times 6, which is the square root of 4 times 6, or the square root of 24 as an entire radical. Negative 5 square root 7 is going to be negative square root of 5 squared times 7, or the square root of 25 times 7, which is the negative square root of 175. And last, I have 2/3 times the square root of 18. Well, if I were to bring this 2/3 back into my brackets, I'm going to end up with 2/3 squared times 18. It's going to be the square root of 4/9 times 18, which is the square root of 4 times 18. It's 72/9, which is the square root of 8. Now, class example 10, we want to do the exact same thing we did without a calculator, and we want to, without using a calculator, we want to arrange the following mixed radicals in order from least to greatest. All right, so a little bit different actually, sorry. What we're doing here is we're arranging these from the lowest to the greatest. Or sorry, from the greatest to the least. So we want the biggest mixed radical, and we want the smallest mixed radical. Okay, well let's think about this. If I have 3 times the square root of 5, 5 times the square root of 3, square root of 15, 6 times the square root of 2, and 2 times the square root of 6, one way we could think about this is if we estimate what these values would be. Well, if I were to bring this 3 square root of 15 into my or 3 times the square root of 5, and this is going to be 9 times 5, or the square root of 45. This 5, if I bring it into my radical, is going to become 25 times 3, or the square root of 25 times 3, and that's going to be the square root of 75. Square root of 15 we can leave as is. 6 times the square root of 2 is the same thing as saying the square root of 36 times 2, which is the square root of 72. And finally, 4 times 6 is going to be the square root of 24. Now I know if I had the square root of, let's just use this as an example. If I had the square root of 4, I know that's equal to 2. And if I had the square root of 9, I know that would equal 3. So I know the square root of 4 is smaller than the square root of 9. So the lower the number of the lower the radicand is, the lower or smaller that number will be. So here, if I select my lowest radicand, which is square root of 15, that's going to be my smallest. So we want to arrange the mixed radicals in order from least to greatest. So in order from greatest to least, sorry, I don't know why I keep saying least to greatest, from the largest one to the smallest one, that means my largest one is going to be b. So it's going to go 5 root 3, followed by 6 root 2, followed by 3 root 5, and then we would have 2 root 6, and finally the square root of 15. All right, these should be enough for you to get started on the rest of the lesson.